Welcome to this video on ratios. Before we dive into the numbers, here's a quick joke. Why did the ratio go to therapy? Because it couldn't find its balance. Now that we've lightened things up, let's get into the serious stuff, how ratios work and their practical uses in everyday life. Our first example is about simplifying the ratio 20-35. To do this, we start by finding the greatest common factor of 20 and 35, which is 5. Then we divide both numbers by 5. So 20 divided by 5 gives us 4, and 35 divided by 5 gives us 7. Therefore, the simplified ratio is 4/7. Simplifying ratios like this allows us to more easily compare quantities by reducing the numbers involved. Next, let's look at a real-world application of ratios in a recipe. Imagine a recipe that requires 2 cups of flour for every 3 cups of sugar. But what if you need to make a larger batch and want to use 8 cups of flour? The key to maintaining the correct proportion is scaling the ratio. We can multiply both parts of the ratio, 2, 3, by 4, because 2 times 4 equals 8 cups of flour. Doing the same for the sugar, 3 times 4, gives us 12. So if you use 8 cups of flour, you would need 12 cups of sugar to maintain the same ratio in the recipe. Ratios also help in interpreting distances on a map. For example, if 1 centimetre on a map represents 50 kilometres in real life, and the distance between 2 cities is 300 kilometres, how far apart are they on the map? To solve this, we take the real-world distance, 300 kilometres, and divide it by the map scale factor, which is 50. So 300 divided by 50 equals 6. This means that on the map, the 2 cities are 6 centimetres apart. Using ratios in this way makes it easy to scale down large distances for easier interpretation. Now let's explore how we compare 2 ratios. We're given the ratios 4/5 and 6/7. To compare them, we first convert both ratios to have a common denominator, which allows us to compare them directly. We multiply the first ratio, 4/5, by 7, and the second ratio, 6/7, by 5. This gives us 28-35 and 30-35 respectively. Since 28 is less than 30, we can see that 4/5 is smaller than 6/7. Comparing ratios like this helps us determine which is larger or smaller when the terms aren't immediately comparable. In this final example, we'll combine 2 ratios, 3/4 and 5/6. To do this, we need to find a common denominator, just like we did when comparing ratios. We multiply both parts of the ratio 3/4 by 6 and both parts of 5/6 by 4. This gives us the ratios 18/24 and 20/24. Now that both ratios have the same denominator, we can combine them. The combined ratio is 18/20, meaning we can now compare or use these ratios together in the same context. This concludes our video on representing ratios. We've explored how to simplify ratios, how they are used in practical examples like recipes and maps, and how to compare and combine ratios. These concepts are vital to understanding relationships between quantities in mathematics and in real-world applications. Thank you for watching, and I hope you found these examples helpful in your study of ratios.